All right, so we're going to be talking about Gauntlt, and Gene kind of talked about this a little bit, but why are we here? We're here because we want you guys to be successful, and we want you to make a difference in your organizations. Here's how you can find me on Twitter and some other things. There's the actual Gauntlt Twitter account, which I usually run, but don't post a whole lot, but we need to be doing better at that. Before we get started, it's kind of like, this is a portion of a talk that I gave to the DevOps crowd over at DevOps Days in California. And I kind of walked them through it, and I think it's helpful for us, even as security people, to walk through our history and where we've been. We used to be cool, right? And we used to have a lot of things. We had the movies, and we were like getting things done and making things happen. And we had our heroes of the hacker heroes, and you were even able to make free phone calls back in the day, and just really enjoy life. And we knew we had totally made it because we were in the Matrix, and they're like running Nmap in the Matrix, and so we have definitely progressed. And over the years we grew up. InfoSec, instead of just being a rogue group of hackers that was doing things for fun, they started making the organizations that they had previously fought with and worked with. But they faced a crucial problem. And that problem was that they weren't able to stop all the viruses and the worms and the security incidents. And we made a big error because we stopped doing engineering. And we started becoming actuaries and insurance salespeople and assessing risk. And we started doing all these activities that just weren't really in the realm of engineering, and it's really hard to pin that down. We instead would say things like, well, this risk is like $100,000, so you could just buy an insurance policy, and we're all good. And we just sort of made up things. And I'm not saying that the math behind that isn't correct. I'm saying it's probably just not the best thing that we could spend doing our time. And there's a really great quote that I'd like to read here, and it's: risk assessment introduces a dangerous fallacy that structured inadequacy is almost as good as adequacy, and that underfunded security efforts plus risk management are about as good as properly funded security work. Who is like struck by that? Does that hit your heart? It should, right? While we're off selling insurance policies, something else happened globally. Devs became cool, right? There's like movies like the Facebook movie, and people are courting developers out in Silicon Valley. And there is a whole idea that's starting to come out where you have DevOps. And DevOps, like Gene talked about, really started. There's a lot of slides that are kind of important in DevOps, and Gene had one of them I'll show next. But this other one is like there's the wall of confusion, and you have the devs saying like, I want change, and operations is like, I want stability, and you can do this for everybody, right? Security is saying like, I want security, or I want control and auditability. But there's this constant battle where we're taking 100 developers to 10 operations to 1 security person, or often there's like 1,000 to 1 ratio sometimes. And Gene showed this slide earlier, but DevOps is the idea of joining these two to provide business value. And I won't go too much more into that because we just set through a lot of that. But code's also becoming social, and so now whenever you're getting a job, people want to see your GitHub account and what you've checked in and how you've impacted the world that way. And they don't want to hear about all the things they've done. They want to be able to see it. And you can collaborate with other people. Also, people don't want to buy a boxed DVD set anymore. They want to use software as a service. And we're moving into the generation where now, like, I want to buy time and availability and those type of things. And obviously we also we sell social networks and relationships and correlation between that. And there's a whole range of companies that have been built up here. And I know that I'm talking to people that already know this kind of thing, but I just want to remind us like where we've come from. But all in the back of our minds, our customers are asking the question like, is this secure? Like, I'm really happy that I get to play Farmville with my friends or whatever, but is my information secure? And and then the problem is that this is the answer that you're going to have to give your customers. And it's not a great one, really, because how many people, I mean, everybody in this room, this is, again, preaching to the choir here, but everybody here knows that certification doesn't really mean much, and lots of certified companies have had their entire databases dumped and put on pastebin, right? Yes, everybody's, okay. And why can't you give a better answer than that? And why is that our only answer, and why is that what we're telling customers? Well, we have that problem where there's that wall of confusion, and there's a divide between your devs and your ops and security. And often, I've had the opportunity to sit next to people and that are like big information security practice owners, or large companies of like 10,000 people. And often, I'm sitting down at this table and I'm like, wow, I'm like really impressed. It's like, I want to hand you my business card because, in the future, maybe we can. It's like, how big's your team? It's like 10, and that's like includes an intern or 2 and something like that. I'm like, 10 people, like, it's impossible to get the work done on that kind of scale. And whenever security is it's like the dev to ops problem has been talked about a lot, because you have the 100 devs to 10 ops, and there's throw it over the wall, and that's been real publicized. But then it goes even further for the security people. The BSIM data shows that 2% of an engineering dev team are working on security. And the BSIM data is collected with like Microsoft and a lot of other big companies and evaluating that. So the quote that I said earlier that talked about how we were moving away from engineering, and we were doing more and more risk assessment. This is from this book, The Tangled Web. And it's a great book, and there's some things that he posits in the beginning. It's a book on browsers, but the first chapter is like worth the purchase price on it, because it really does a great overview of where we've come from since like the 50s in security, and would totally recommend it. But you have the idea that you can learn from other people's mistakes, and hopefully you learn from mistakes, but also hopefully from other people's. We need to develop tools that correct problems, and then we need to have everything plan to have everything compromised and be thinking in that direction. And at the same time, Gene also talked about this morning, but I want to mention again, is rugged. I came across rugged in like May or April 2010, and I was working at National Instruments here in town, and we were working on doing a lot of DevOps stuff. And my friend Ernest, I think it was Ernest in the crowd. Oh yeah, all right. So we were chatting about this, and it was like, how do we make our software more rugged? And we started looking at this, and when you start talking about rugged software, people in the organization really start paying attention, because they don't really want security. They want rugged. And I won't go through all the slides because there's some great presentations already out there. But current software is the dilapidated house that kind of stands up, but you can't really defend it. You don't really know what's coming in and out. You don't have any idea. But we need rugged software to look like this. This is like rugged by analogy. Well, rugged also hinges on one requirement, and that's adversity. And if you saw Gene's talk, he mentions the chaos monkey, and that's a good way to put adversity inside of your organization. And so it's, adversity is things that stop your normal operation, and it's either real or perceived threats. Well, there's a picture of the moon in the background here, is because I believe that as you try to build things like NASA did whenever they were getting to the moon, you come up with cool innovations later, like the Tempur-Pedic mattresses that now we can all sleep in comfort, or those like really neat pins that can like right underwater or upside down. And but we'll have lots of benefit if we start doing testing and ruggedization of our software in other ways that we didn't really think of. And it's very familiar in the physical world. We have the whole idea of no pain, no gain, and it's very common. In our industry, we've just been able to get away with it for a long time. At South by Southwest earlier this year, Cloudflare was talking about how they defended the Lulz network, Lulzsec attacks, and they were just kind of recounting the whole story, and it was really great narrative. But they were saying that our network really got a lot better. Like sometimes they were like, maybe we should just like stop fronting their services, because people are trying to take them down while they're trying to keep it up, and there's all these things. But they said, it really helped our network in a huge way, and so we're actually very thankful for it. And so security looks like this, where you have absence of events, you have high cost, it's usually negative in your environment, where rugged starts with affirming values and showing positive benefit here. And so I like the idea of rugged by design, but DevOps by culture. And so that's where we start talking about rugged DevOps. And rugged DevOps really speaks to a lot of the same things that both the groups are talking about, and just is putting another word. But this is what I call the 6 R's of rugged, where it's repeatable steps, they're reliable, it's reviewable, so your audit team should be happy. It's rapid, so you're able to deploy quickly, and you're able to release, like Gene was talking about this morning. You're able to reconfigure quickly, and the DevOps world is embracing a lot of this with tools like Chef, Puppet, CF Engine. We had one here at National Instruments called Pi, and so it was really cool. And they're already kind of on that process, and they're making that happen. Well, this is where we come up with Gauntlt, because I hope that by now you kind of feel the need. So the rest of the slides from here on out are going to get more technical, and we're going to dive into like what Gauntlt is. But we want to. Oh, thanks. You can't clap for that. Come on. Well, that's good. It's like the build-up, right? So now we will be talking about Gauntlt. And so the idea of Gauntlt is to, we have all these continuous integration systems and how we're going to inject that. And so the idea is you have an attack from all sides. And in the Gauntlt, you would take your web app and you would say, here you go, web app. You're gonna run the Gauntlt today. And let's see the animations. So plus animations. Can I get a clap for animations? All right, sweet. Yeah. But yeah, so the idea is that you can take these tools and harness those in there, and then now you're going to start doing security testing in a DevOps world. So before you deploy, you start being able to do that testing right then. And so now you're not getting audited and once a year, but you're doing it like every day or every time you check in and things like that. So it starts putting attacks in, putting in always attacking environment for developers with attacks written in easy to read language that helps the cross-communication boundaries between all these groups. So we see that security domain knowledge is generally a mystery to dev teams, and our goal is communication. And so we're really trying to take all this stuff and put it together. Gauntlt has Ruby and Cucumber as kind of the backbone of it, and we'll say more about how it's built a little bit later. But you can get Gauntlt on GitHub. The project is called The Gauntlt with an E. We couldn't just get Gauntlet, and then Gauntlet without a E for the actual project because, because really it's because the other Gauntlet was taken in Ruby gems, and we wanted it to be easy. So how do you install Gauntlet? You do a gem install Gauntlet. We just released the 0.1 version, let's see, was that Sunday night, Monday morning? So we've had a couple versions since then, but that's our AppSec release. And download a couple attacks, and we'll talk about what those are and how those are set up. And then you just run Gauntlt from that directory, and it parses there and pulls those up. All right, so let's walk through that a little bit further. You go to the GitHub, there's the example attacks, and now you can run it. And when you look at these slides later, you can grab the link at the bottom. Let's look inside a couple of these files, and here's the Gauntlt attacks here. Okay, so this is just an in-map attack because Trinity can use it, we can also use it. And people were paying attention earlier, right? All right. Okay, so we have up top we have a slow flag. So this is an attack that's going across the network. So we give it some extra time to run, and we're going to be running against example.com. And we say we're going to hit these ports, and then we just run a fast nmap scan, and we're just checking that it should contain this port 80, and then below it doesn't have port 25 open. So you can see it's pretty easy language here. So it's just like some givens, when, and then here's what I expect. And then it calls out to some command line things. We stubbed in some values here, and we'll talk about that a little bit more. Here we go. So when you run Gauntlt for the first time, it'll parse the directory. It'll parse the directory of that you're in, and it'll look for anything with the .attack extension. And once it does that, it'll pull through here, and it says like, yep, I checked in, map was installed, and I set the host name right, and I did all those things. Oh, but I was checking, and 443 was not open, so that's a fail. And then you go back again, and you look at it, and you see I'm going through again, and I launch it, and it does pass. So now I heard there's this company called Netflix. Everybody hear of Netflix? They're like Google, yeah, but they're for movies. They're like way better. So I'm going to be joined by the illustrious Jason Chan from Netflix, and
thank you, sir. everybody. I just have a few slides here. I just want to kind of jump into an example. Maybe that'll give a better sense of how you can use it. So I work in the engineering organization on various cloud security issues. So what we wanted to do with Gauntlt, or I'll start with the problem first. So Netflix uses AWS, Amazon Web Services, pretty heavily. We provide self-service deployment for dev teams. You might have heard mentioned in the keynote some of the stuff we do around Chaos Monkey. We do about, I have a longer talk tomorrow, and I was doing some numbers. We do about 300 test deployments a day and about 80 production deployments with several hundred different apps. We use Amazon's ELB, which is their load balancer, to provide a bunch of different services, primarily load balancing across data centers. So the problem with ELB is that if you attach an app to an ELB, there's no security associated with that. So if you are attached to that ELB, now the internet can now access your application. So that's a good thing if it's a public web service. It's not a good thing if it's a private app that you didn't intend. So one of the problems that we had is we have this self-service environment, and you may have developers who don't really understand the security issues associated with ELB. So the question then is, if we have hundreds of these clusters, hundreds of ELBs across many different environments, how do we make sure that they're configured as we would like them to be? So what we wanted to do with Gauntlt was, well, let's see if we can use Gauntlt. Let's try to make a real life use case and actually have it organized and perform testing. So what we proposed to do was create, basically, if you contact a load balancer from just some arbitrary untrusted internet system, what would be the response? So if it was supposed to be a public server, then you would get back 200. This is just an HTTP response code. And if it wasn't, you would get something else depending on how that site was configured. So our process was, we use Jenkins for continuous integration. Through Jenkins, we launch an instance that has Gauntlt loaded on it with this notion of a master list of all the ELBs we know about and how they should be behaving. So that's kind of what we know and what we expect, but right before we run the test, we actually pull the current list because there may be things new in a self-service environment. There's new things popping up all the time. And then I actually, instead of my approach to the attack files, I create a separate attack file for each listener on the load balancer. And then basically just execute the attacks. And then if there's a new ELB I don't know about, that should be an automatic failure because I don't know the context of it. Should it be public? Should it be private? So that will automatically fail. And then anything that I knew about but its behavior has somehow changed, that would also be a failure. And then we just triage those findings and update that master list. So James mentioned that it's kind of a Ruby, a Cucumber. I don't know Ruby, so I'm more of a Python person from a scripting perspective. So what I did was when I created the attack template, I wrote a little wrapper file in Python to generate these attack files. And Gauntlt actually has a built-in feature that leverages curl, which I'm sure you're familiar with. So you can do kind of these arbitrary tests with curl. So what I did was from my master list, I just sub in the sort of whatever the configuration parameters are for that particular ELB, generate a specific attack file. This is the template right here. You can kind of imagine how that would get populated. And then the curl command line, all it does is just check for the status code. So 200, 301, whatever it might be. So that was just kind of an example. That's all. Not sure how many. Oh, all right.
Okay, so I'm a programmer, like Programmers Anonymous up here. I'm going to explain a little bit about how Gauntlt works, and you'll also get a crash course in Cucumber, but you won't notice it. All right, a little bit about me. That's me. My name is Mani. I'm a software engineer at Zest Finance in Los Angeles. I have lots of experience, good and bad, in web development, Ruby, test automation, and I'm learning Clojure. As I said, I'm a programmer. I have to say something like that. All right, so James mentioned communications, and if you saw the keynote by Gene Kim, he talked a lot about how different groups work together. There's a lot of things that are nice to have, like it's nice to have a beautiful view out your window, right? But communication is not a nice to have, it's essential. And one reason for that is because it's really what determines what your software looks like. There's this really cool concept called Conway's Law, which says any organization that designs a system will inevitably produce a design whose structure is a copy of the organization's communication structure. So, you know, if you have a really rigid separation between teams and everything is a long negotiation, multiple meetings, that's what your code is going to look like, right? If you just have a bunch of dudes like straight out of college, you know, just doing whatever they want. Hey, dude, did you like do some security? Yeah, whatever, you know. That's what your code is going to look like too. So, you know, it's not about more or less communication, it's the quality. And that's really the core of what Gauntlt aims to do. So you might look at it and say, hey, I could do all this stuff myself, but you're missing the important thing that Gauntlet is providing you, which is improving the visibility and the transparency. So if you have a lot of automated scripts that do cool security testing, who can understand those? You know, like, where's the documentation? So the idea is to merge the actual test and the documentation into one thing. So we either have to pick, you know, a programming language or, you know, a human language, right? So us programmers lost. I have to go with the human language. What are you going to do? So this is where behavior-driven development comes in. And the idea of behavior-driven development is to really focus on communications. This is like the official definition. BDD is the second generation outside-in, pull-based, multiple stakeholder, multiple scale, high automation, agile methodology. It describes a cycle of interactions with well-defined outputs resulting in the delivery of working, tested software that matters. So this was written by a programmer. Everything, all that stuff is just meant to make him seem awesome. All you need to care about are those three bolded words, software that matters. So the idea is, let's build stuff that really delivers value. You know, so not just fancy buttons like money, right? And a lot of times programmers work on things for, you know, weeks, months. It doesn't deliver value. The idea of BDD is to have this constant feedback loop. Make sure everything you're working on is delivering value, and also figuring out ways of delivering value for a lower expenditure, right? You know, if you want security, you don't need all the bells and whistles of a fancy login form, right? Like, a lot of that stuff's not delivering security. So Gauntlet is about taking some of these ideas from the realm of behavior-driven development and applying them to security. And Cucumber is kind of like the standard bearer of behavior-driven development. This is just like a screenshot of the Cucumber website. So you saw that file that James showed, and Jason also had an example. You basically have a few steps to do BDD. You describe the behavior you want in plain text, right? So that's the English step. This is what your feature is. That's the documentation. And then here's the key concept. You can actually execute that code or that text. I guess to me, all text is code. But so you write something down. It's like documentation. People can read it. But a program will go and execute each line in there. And so the key is, it's not magic. You have a mapping for each line to some code that does something, and it verifies the output. And so you start out with your behavior. You don't actually have any code, right? It fails. You write the code. Everything passes, and you keep going like that until everything works. And then number 7, it kind of snuck in there. And it's really important to do until your money runs out and you're bankrupt. So if you don't do that, you're not truly doing BDD. All right, so let's move on to the English specification file, which we call an attack file. It's plain text, and it uses this Gherkin syntax. It's really simple: given, when, then. For those of you who are not familiar with gherkins, I think that's British for cucumber or pickle. All right, so here's what one of these looks like. It's plain text. There's like feature, scenario. You can have multiple scenarios. There's also some fancier stuff you can do to basically have a bunch of similar scenarios, but we're just going to focus on the basics. You can see given, when, then, right? Now, it's a very free-form format. You could have, 58 givens, 27 whens, and you could do given, when, then, given, when, given. Like, you could go crazy with it. It's up to you. Use your judgment. It doesn't enforce anything, really. So let's take a look at this in action real quick. another example. So I'm just running this SQL map example. And so there's a file there. I gauntlet that file, and I see some green. It actually did quite a bit right here. What you see in the light blue, those are actually system commands that are being executed as part of the attack file. So it's going into directory, it's running a Python script, it's parsing some output. It's actually doing quite a bit. And the cool thing about this is you can just grab this. I mean, it's all going to standard out, it has an exit status. So it gives you a full report of what it did and what the output was. All right, so let's take a closer look at what we have here. So the first part is the given. This is the setup. And this is actually one of the key benefits of using Cucumber. You have to really be explicit. What are the assumptions behind this operation? You know, we're dealing with a URL here, right? That makes sense in this context. If you're testing something else, it doesn't make sense. If you were testing something like a load balancer, you would have to say, given I have a load balancer configured like this. And we also have one which is, you know, it says given SQL map is installed. So this file is really meant to work with SQL map. If you didn't have SQL map, it wouldn't make sense to run this file. But just to be safe, we actually verify. And a lot of times what happens is you'll have some small environmental issue and your whole test will fail. So this allows us to really quickly let you know, hey, you need to install SQL map, or you need to put SQL map in your path. So we verify it's there, and then we set these configs. So when I say the target URL is whatever, it's actually going to create a variable that I can use later on. And Jason took that to the next level. He's actually creating a template that generates these. And since it's a plain text file, you can go crazy with it. So the next part is the when. This is where the actual attack happens. And so when we launch a SQL map attack, SQL map is a Python script. We chose to make everything really transparent. So you actually have Python in there. And that's going to be executed on the command line directly. So what we provide is this environment parameter, SQL map path, which tells you where to find the Python script, and the configuration value that we set up there. You could do whatever you want there, and any command line script will work. And that allows you to be totally flexible. And then you'll also know exactly what's happening. So it forces you to write a little bit more and to know more about your tool, but at the same time you get total visibility into what the system is doing. It's not just all plain English, like when I launch a really good SQL map attack, you know exactly what you're doing. And that will help you to figure out whether, if you run into an issue, it's a problem with your test or with the actual system that you're testing. So here's the then. This is the assertion. So this is what you expect. And what we're doing here is just checking what the output was. We're looking for a specific substring in the output. You can be much more complex in what you do. But for the most part, looking for strings works just fine. Most tools give you an output that will tell you whether it passed or failed. You can also check the exit status. If something fails, then that's bad, right? You're trying to find this needle in this haystack. So a lot of tools, especially SQL Map, give you a lot of output. So you're going to have to get familiar with the tool that you're using and try to figure out what really matters to your system. In this particular case, we're trying to find SQL injection, and it has a really nice little statement, I found SQL injection. A SQL map is kind of a weird tool. It fails when your system is safe. So if it finds no problems, it fails, and it's like critical. It's critical because you are not in a critical state. So you have to know about the tool. You can't make assumptions. But I think that's something that you would have to do anyways. All right, so how do we test SQL map? Well, we're trying to find SQL injection, right? And to do that, we need a website that's vulnerable to SQL injection. This is a problem we came up against a lot developing Gauntlt. People don't like us to just attack their websites left and right? So we came up with a little tool called Scapegoat. And basically, Scapegoat is going to give us some unsafe web apps that we can use for testing of Gauntlt itself. So, if Gauntlt works on this totally insecure site, then at least it does something. So here we have a little form, and it'll do a little form lookup, but it's not doing any filtering of any kind. So it'll execute that whatever you put in there straight in the database. And it went kind of fast through there, but basically this is the kind of form where it's like you're trying to look up one thing, and by passing it raw SQL, you could look up everything in the database. So imagine that was like your list of users, right? There you go. You got owned right there. So we're running SQL map against this, and this is like something that came out of Gauntlt, but it might be useful in general. We can develop these tools further. That leads us into the discussion of the attack adapter. What makes the SQL map attack work? And so we have some support tools that will allow you to more easily run things like SQL map. You have the step definition, which is the mapping from the English to the code that gets executed. You'll have some support code. So that Scapegoat little web app, that's some support code. It's a Sinatra web app. It's, and you can also do Java. I don't know much about Java, but we have JRuby support. So there's a lot of security tools I know in Java, so you can include those as supporting libraries. You can also have shell scripts. SQL maps itself a Python script. So, and Jason was using the Python script for his templates. And this is what it looks like. I'm just showing you this to let you know it's not magic. You have to write some code if you want to create an attack adapter. But that's really for more advanced users and developers. Our goal is to give you a lot of attack adapters that you can use without writing any code at all, just writing attack files. So this is Ruby code here. You could use other languages, but Ruby is going to be probably the easiest. And this is where we're interpolating those environment variables, and that's where we're executing the command on the command line. So if you have something in your attack file that's bad, like when I launch an attack with rm-fr/, it's going to do it. So don't blame me. Gauntlt is designed to be simple. Simple is a very clear kind of philosophical concept. It's something that's not like interleaved, right? It does one thing at a time, doesn't require you to know about 10 things. And that makes it also extensible. So it fits into the Unix pattern. It's like a pipeline. It takes in some input, it puts out some output. And people have done some really interesting things, like Jason's example with templating. I wouldn't have thought of doing that. But because it's simple, it's really easy to make it useful in almost any situation. And we've got a bunch of features coming up. We're going to have more output parsers. We have XML currently and raw string. We'll have more like JSON. More attack adapters. We have, I think, 6 different attack adapters. There's a whole bunch of them that we're working to build, including some for big scanning tools like Zap that are not simple command line things. More goats. So we have the SQL injection goat. And these are pretty helpful, to figure out what you're going to do in your testing. And more support for JRuby and Java. Also, anything you want. So if you are interested in some particular feature, we try to be really responsive. Go to our website. You can create a new issue. You can email us. We've been really looking to get feedback from people and make Gauntlt as good as we can. And with that, let me pass this off to Jeremiah.
You hear me okay? Great. All right, so I'm talking about the Gauntlt starter kit today. It's separate from Gauntlt. What this is an easy way to try Gauntlt out. What I'm hoping to do with that is take Gauntlt off of that list of things you want to try out someday, put it on that list of things that you already tried out later today. So I'm Jeremiah. I am Application Infrastructure Manager at K-State. I've been doing this kind of stuff, security, Unix admin for 18 years now, and had to throw in a little reference to my birds. I've got chickens and ducks. If you look for my bio in the book, they're in there too. So if you needed a random fact about me, you got it now. So Gauntlt starter kit. What we're trying to do here is just give people a really easy way to try this, and so we wanted to keep the dependencies as small as possible. So looking at this crowd, I'm thinking there's people here who use VirtualBox probably just about every day, right? And yeah? Okay, so that one's not going to be hard. Who here has used Vagrant? So look around. Keep your hands up. I want people to see who you are. If anybody here wants to know how cool Vagrant is, ask those guys. Because this is something that if you're not using it now, you probably do want to be using this. And what it's going to do for you is you're building lightweight, reproducible dev environments in VirtualBox VMs. Later, there's going to be support for other virtualization solutions too. That's coming pretty soon. So if you don't have them already, get those things. These are the URLs. And the starter kit itself is on GitHub. So go to the same place that the same project page, and this is in a different repo. You want to download the starter kit, you can clone that, and you can also get a copy off of gauntlt.org maybe. Is it there yet? It'll be there soon. So you'll need a base box. This is part of using Vagrant, and so once you got Vagrant installed, you're just going to add that, and we're using one called Precise32, an update that we'll have shortly. We'll probably just have that happen automatically when you do the next step. And it's as easy as clone the repo, change into that directory, and Vagrant up. And it's going to do everything else that you need to get an environment set up that's got Gauntlet, but also all the dependencies. You know, if you want to do the Nmap attacks, you got to have Nmap. If you want to do SQL map, you got to have that. The starter kit's going to put all that in there for you. And so when you run Vagrant up, it's going to run for a little bit. I sped this up quite a bit. When you're doing this for real, especially if you're on a slow network, good time to go get some coffee. If we could always have it run this fast, that would be great. But once it's run, you're good to go. And how did it do that? With the Vagrant file, this is the core of what you're downloading when you clone the starter kit repo. So I'll just point out a couple of things here. Figure a key that you'll use later at SSH in. What's the box that we're using as the base to bring that up? And then Chef. And I'd love to go into Chef here, but this is not that talk. So just know that that stuff's all getting pulled in when you run Vagrant up, and that's going to configure that system for you. Only other thing left to do outside of running the attacks is Vagrant SSH. And I do have one thing to say about Vagrant, which is by default, all the VMs that it creates use a standard set of keys for SSH. You know, there had to be some default way to make it work for everybody, but I changed my keys. A lot of users changed their keys, and you're going to want to do that too in this crowd. So this is the command to do that, and I'll put that up on the Gauntlt site too. So I just got a couple examples here running attacks, similar to the things that we saw earlier. But what I wanted you to see is that we're doing this now inside of this Vagrant VM. So Vagrant SSH, you're logged in, run Gauntlet, and then we got some sample attacks in the attacks directory. So Gauntlet attack/nmap, it's going to run it for you, and there you go, you're trying it out. You want to edit that file, hit a different site, hit one of your own, just edit that nmap file, and you could put different ports or anything else you want to do there. And at that point, you will have had a chance to try out Gauntlet with very minimal effort to get started. You want to run this in production? I wouldn't do it this way, but we've got good documentation on the website and the READMEs in GitHub that will give you those instructions. Another example here for using SSLIs. And I want to leave you guys a little bit of time for questions, so I'm going to not leave that up there too long. But what I've been saying, the point of this is I want you guys trying this out. So when I see you all later, I'm going to be asking. I'll recognize each and every one of you. I'm going to ask, have you tried this out yet today? So I want to hear some yeses. And on top of that, we've got office hours tonight, 10 o'clock, hotel bar. If anybody's got questions, anybody thinks they'd like to try it out, anybody wants to contribute, we would love to have some people contributing to this project. 10 o'clock tonight, we'll be hanging around the hotel bar. We'll be easy to recognize because of our shirts. And all right, oh, one other thing. I'm going to throw out the free node. So we're also on IRC, free node at #Gauntlt. So for you IRC users, we've usually got somebody in there, maybe a little slow to respond, but it's a good place for questions too.
But any questions? Yeah. Yeah, we are MIT licensed. So yeah. Okay. You want to answer that?
I didn't know how cool Clojure was yet, but I'll probably rewrite it in Clojure. Just no. I mean, I did Ruby, and Ruby's really advanced in terms of testing. It's probably the most advanced in terms of testing of any language.
Okay, but yeah, we do think of the environment, in the new world where people are selling time and all that kind of stuff, we are, we believe that runtime is the thing that you really want to test and make sure that you push that through there. Not just like, production, but, QA and all that stuff. But we do have some generic attack adapters, and we are looking at even calling like third-party APIs for things like, let's say you have a Qualys or something like that that you want to hit. We've had people talk to us about that, but we haven't had anybody with license key in hand to say we want to do this kind of thing. But code scanning and things like that are possible integrations. We just haven't did that. But money.
Yeah, I mean, I'm not smart enough to do static code analysis tool. There's somebody there who's got one. It's really actually the opposite of what we're doing. So we're looking at the system as kind of not a black box, but a gray box. We're looking at the running instance. The difficulty with code analysis is like, what is it? Is it Java? Is it Ruby? Is it this framework, that framework? And so that is something that is part of the mix. You could use Gauntlet to run a code analysis tool, and then like say my code analysis tool. Yeah, you can call out to a code analysis tool, but Gauntlet itself is kind of the opposite of that. It's just like we don't know what's going on inside your app.
Hey, yeah, we're actually out of time, so we got to keep the time. But we are having office hours tonight at Hotel Bar at 10 o'clock. The three of us will stick around here. Jason's talk is tomorrow. What time is that at 1. So you definitely want to check out the cloud security talk with Netflix and Jason, because it's going to be pretty epic. So, all right, thanks everybody.